Hello everyone. In today's class, I will introduce the definition of homogeneity and the demonstration of auto shimming in NMR. First, I would like to introduce magnetic field homogeneity of NMR. Magnetic field homogeneity refers to the uniformity of magnetic field within a specific volume interval. That is the equal degree of the number of the magnetic field lines passing through per unit area. This is a C-type magnet. The lines of force drawn inside this magnet are very uniform. But, in fact, the magnetic field is uneven. There are certain differences in different regions. For example, this region and this region, there could be magnetic field inhomogeneity between them. The difference in magnetic field are at different locations can be described by the parameter of magnetic field homogeneity. In NMR, we can collect FID signals and then Fourier transform FID signals. After the Fourier transform, the signal in the time domain can change to the frequency domain. We can get a spectrum that look like this. We can then measure the half width of the spectrum to get the indicator of the homogeneity of the magnetic field. For example, if the height of this peak is h here, then we measure the difference in the corresponding frequency of a half h. And finally, we can calculate the index of the magnetic field homogeneity. According to NMR theory, the resonance frequency of the nucleus in the magnetic field can be calculated by Lamour formula. Omega 0 equals to gamma multiplied by B0. But actually, a delta B can be added to the formula. Delta B describes the inhomogeneity of the magnetic field. If the magnetic field is absolutely ununiform, delta B equals 0, then the FID signal contains a signal frequency. Omega 0 equals to gamma multiplied by B0. The Fourier transform should be followed by a spectrum of signal frequency. It should be a straight line perpendicular to the horizontal axis, which is the ideal case. But what we actually get is a broadened spectrum, mainly because of the magnetic dipole interaction between the nuclei and the inhomogeneity of the magnetic field, which causes the broadened spectrum. The more uniform the magnetic field, the narrower the peak of the spectrum. The more uneven the magnetic field, the wider the peak of the spectrum. Therefore, we can measure the half-width of this spectral peak to obtain an indicator of the magnetic field homogeneity. Magnetic field homogeneity describes the uniformity within a certain range. In general, we say what is the homogeneity of the magnetic field over the range of a DSV cipher. sphere. In NMR, magnetic field homogeneity is measured in units of 1 million of the main magnetic field. Let's call it ppm. It can be calculated by this formula. Well, delta F corresponds to the half-width of the spectrum, and gamma multiplied by B0 corresponds to the central frequency. Suppose the center frequency of this device is 100 MHz. Delta F is 300 Hz. So if you look at this formula, 300 divided by 100, that's the magnetic field uniformity of 3 ppm. Later in the course, when we demonstrate the experiment, we will use the formula to calculate the magnetic field uniformity index. Now let's talk about effect of the magnetic field homogeneity on NMR applications. The first is the effect of magnetic homogeneity on MRI, because MRI requires spectral coding, including the layer selection coding, phase coding, and frequency coding. Linear gradient magnetic field needs to be applied. If the homogeneity of the main magnetic field is poor, it may lead to coding deviation, resulting in image distortion and deformation. This picture is the one that I found on the internet. On the left is the imaging effect before shimming, and on the right is the imaging effect after shimming. We can see the difference before and after the shimming. The second one is NMR spectroscopy. NMR spectroscopy is mainly based on the principle of the chemical shift. The same nucleus have different resonance frequencies due to the different chemical environments. This difference can be described by chemical shift. The homogeneity of magnetic field is very important for NMR spectroscopy. For example, in the figure, the hydrogen nucleus corresponding to the arrow here is influenced by the carbon atoms, while the hydrogen nucleus on the left is influenced by the oxygen atoms and carbon atoms. So their chemical environment is different, and there is a chemical shift. If the chemical shift of the two hydrogen nuclei is 3 ppm, but the magnetic field homogeneity is greater than 3 ppm, then we may not be able to distinguish the frequencies difference between the two hydrogen nuclei due to the influence of the magnetic field homogeneity. Therefore, the experiment of the chemical shift requires higher homogeneity of the magnetic field. The third one is relaxation analysis. Relaxation analysis mainly studies samples based on the speed of the relaxation time. The homogeneity of the magnetic field will affect the speed of the signal attenuation. Ideally, the relaxation signal decays at T2 because of the inhomogeneity of the magnetic field. Signal decay will be accelerated. Our measured relaxation process T2 star is actually decaying. There is such a correspondence between these two parameters. That is, the signal we measure is a theoretic one pulse the plus the effect of the magnetic field in homogeneity. From the expression, we can see that T2 star is less than T2. In our demonstration experiment, shimming is also carried out by observing the speed of the signal attenuation. The second way is mechanical shimming. The mechanical shimming method is to adjust the parallelism of the magnetic poles. That is, to adjust the parallelism of the upper and lower poles. The effect of the homogeneous field is achieved by adjusting the parallelism of the upper and the lower poles. This is also done in the NMR factory. The third way is the auto shimming. That's the experiment we are going to demonstrate later. Auto shimming is based on a gradient coil. We can set a corresponding gradient parameters in the software, including the magnitude and the direction of the gradient current. When the parameters are set, the corresponding current is sent to our gradient coil, where the corresponding magnetic field is generated. When the magnetic field generated by the gradient coil is superposed on the main magnetic field, the effect of the homogeneous field can be achieved. The corresponding structure of our device is as follows. Each magnetic pole has a gradient plate, and each gradient plate corresponds to the gradient coil in the X, Y, Z three directions. We can modify the current magnitude and the direction of the X, Y, Z gradient directly in the software, and we will see that later in the demo. And that's all for the course. The operation of the experiment is separated to another video. Thank you.